Welcome to our lesson about curvature. Our graphic area shows 4 separate surfaces. Let's take a look at the supporting sketch. Right-click, Edit Sketch. This entity was created using 2 lines and a fillet with a 2 mm radius. The lower surface I created with a spline. Let's exit this sketch and go to the Evaluate tab. Select Curvature. If this tool is not available, go to Customize, the Commands tab, View, and here's the icon. Just drag it up to your tool manager. Let's cancel out of this window. When the Curvature tool is active and I drag my mouse over a surface, I see the curvature volume displayed in callout. Let me mouse over the fillet. I see the curvature value of 0.5 and the radius value of 2 mm displayed. Now let's find out where this curvature value comes from, what it means, and what the colors associated with the curve values mean. Let's go to Options, Document Properties tab, and click on Curvature. Curvature ranges in value from 0 to 1, and here we've got a color scale that represents these values. Curvatures close to 0 are represented in black, and this is basically a flat surface. Curvatures closer to the value of 1 are represented in red. The geometry at the level of 1 has an infinitely small radius, or you could describe this geometry as a corner. Let's take a moment to understand where the curvature value comes from. Curvature value is derived from an equation, 1 over the radius. In our example, the radius was 2. 1 divided by 2 equals 0.5. That's our curvature value, 0.5, and it's represented by this dark red color. Let's cancel out of the curvature window and cancel out of the options window as well. Let's make some modifications to our sketch. I'm going to increase the radius value of this fillet to 30 mm. Let's exit the sketch. The fillet is now green and the curvature value displays as 0.33. Let's return to the Options dialog window. Curvature. Here we can customize the scale of the curvature. I'm able to enter a new value, let's say 0.4. If I only make this one change, then we don't see any difference in the color spectrum on our part in the graphic area, as you see here. Let's open the curvature scale again. Curvature. The reason for this is that the curvature value of our fillet is very close to this value, or the color bright green. That's why we don't see any change in the graphic area. Let's change this value, let's say to 0.06 for example. Click Apply. Now the curvature value of 0.033 will be represented by this dark curry color here. It's no longer the bright green color. Let's make some more changes in the spectrum so that the color representation in our workspace is even more noticeable. Let's click OK to exit. And now you see that the color of the fillet segment change in the color of the surface below has a more even distribution of color. Alright, let's move on. We'll hide Surface Extrude 1. And let's make Sketch 2 visible. Let's right-click and edit the sketch. My sketch consists of a 3-point arc and a spline. This spline looks like a line, but a spline between 2 points is effectively a straight line. I've pulled in these entities to help us review the difference between tangency and equal curvature. Let's begin by selecting both of these entities. Let's right-click and select Show Curvature Comb. The curvature comb displays around the arc. The arc has a constant curvature, the value is 0.075. And the comb displays this value in the graphic area. The spline, though, has a curvature of 0. This effectively means that the 2 segments, the arc and the spline, have an intersection, but they don't share tangency or curvature. Let's select this intersection here, and we'll add a tangent relation. As a result, we've got 2 curves that are tangent to each other. However, as you'll notice, the curvature comb at the intersection point is a different height than the curvature comb around the arc. If I mouse over this curve close to the joint, you see that when I mouse over this point, the curvature value jumps. Now you may be wondering why this is important. Well, when you're working on transitions between surfaces that have neither tangency nor equal curvature, the transition is a straight edge and will be more noticeable. When you have a transition between surfaces, when one surface is tangent to another, the transition, while still present, will be much less noticeable. If two surfaces share tangency and equal curvature at the transition point, then the transition will feel like a single continuous surface. Let's try this out on my example. We're going to apply equal curvature to our curves. The comb now shows a smooth transition between the two curves. When I mouse over, the curvature value matches a lot more closely than it did previously. Okay, let's exit the sketch. And let's go to the Surfaces tab. Activate the Extruded Surface command. The color transition between the arc and the spline looks pretty smooth now. The last point I wanted to discuss in this lesson regards the difference between tangency and curvature. Let's take a normal 2 view. I want to create a demonstration using a construction line. My line's going to originate at the center of the circle, and it'll go through this line. Let's place a second construction line now. It'll be normal to the first line. Right-click and select to exit the tool. My second construction line is tangent to the 3-point arc at this point. If you're having some trouble grasping this concept, you can think of it this way, that the line that's tangent simply continues out from the meeting point in the same direction. However, mathematically speaking, a tangent line passes through a point on a curve normal to the radius vector. The curvature is the amount by which a geometric object deviates from being flat or straight in the case of a line. Let's try another example. I'll select the end point of my second construction line and the end of my spline, and then merge them. Now I'm going to create a spline between this point and this point. Right-click and select. Let's shift-select the spline and the curve and add a tangent relation. Here we have a graphic representation of the difference between two curves that share only tangency and two curves that share tangency and equal curvature. And this concludes our introduction to curvature in surface modeling.